In this video, we're going to finish up the material from chapter 13. So the last video was a fairly long one. This one should be a little bit shorter. So this one deals with the concept of templating or templated functions or templated classes. And it just allows us to treat the type of a function or the type of the input of a function as a variable. Okay, so the example I have on the screen here, we have a max function. Okay, so this is for integers. It takes an integer A, integer B, okay, and it's going to return if A is greater than B, returns A. If not, it returns B. We don't care if they're equal, it's going to return one or the other. And in this case, it actually would return B, but it doesn't matter because it would be the same in that case. Okay. So this is a fine function, no problem with it at all. But if we tried to use it on doubles, it wouldn't work. So we'd have to create another version of it for doubles. We'd have to say, double max, double A, double B, and all the rest. And repeat the rest of it. Well, what if it's for longs? We'd have to do it differently, or floats, or whatever it was. Okay, chars. Chars have a numeric value to them. Strings have the equivalent of a numeric value. So we would have to write a whole bunch of different versions. And we can do that because we can overload the functions, which is not a big deal. We can rename them, not a problem, but it's just a lot of work. Okay. What if we could make this generic function where int is replaced by a variable that could be determined at runtime? Okay. So that's kind of the idea behind templates and how they work. So let's take a look at an example when we have just a function that uses templates. Okay. So got this one. So this is going to be that max function again. We're going to call it find max in this case. But what's different here is this keyword template. Okay. And then our type name, capital T. Okay. I think the book calls it something different, something E type or something, EL type, whatever. Call it whatever you want. The T doesn't matter. Okay. But T is a variable that holds type. Okay. So we can then define our function here as find max. The return type is T, whatever T is. It takes a variable A of type T and a variable B of type T. Then we have our same exact things we had before, okay? And it's going to return those variables, okay? Now to use this, we can go ahead and create some different types here. So we've got int1, int2, double1, double2, char1, char2, okay? And we can just send along to the find max function whatever it is we want, 2 ints, 2 doubles, 2 chars, okay? In this case, the type for T will be inferred by what's being sent. It'll know what to do with it. It'll be fine. Okay. So rather than having to write 3 different functions for find max, we can write just one. Okay. When I go to run this, okay, so do a G++ on function template example, but I want to do my -o function template example.exe. Okay. Okay. Do a dot slash that. We see the max of 10 and 20 is 20. The max of 10.5 and 7.5 is 10.5. And the max of A, the character A and character Z is Z, because Z has a bigger number. Okay. So that's the idea. It's really going to help us out. And a lot of times, right? We can write a function once and it can take any type that we want to send it, which is good. Okay. This is going to become important to us when we get to our data structures. So one of the chapters earlier had at the end this example of a list of some type. So they would do like a list of integers. You had to do all the stuff for. If you want to do a list of doubles, you'd have to do a whole other list with doubles instead of heads. Okay, we can use this idea of templated variables in our class definitions as well. Okay. And the book goes through the whole big example with lists, and you can go through that. But I did a simpler example here This one we're going to create something called a box. It could be a box that holds an integer, it could be a box that holds a double, whatever. Okay. So let's take a look at this code. Okay, that is called class template example. Okay. So just like before, we have our template, we have our type name, T. That's not going to change. Okay. We now have defined our class box. Okay. It's a box that holds one thing. Okay. And what it holds is the value of the box. It's of type T as well. Okay. So now when we go to do all the functions we normally do, instead of us knowing what type value is, we just know it's of type T. So we have the constructor then becomes whatever T is. And we'll have we'll show here in a minute how we're going to let it know what type T is. Okay. It's going to set value to be of that type. Okay. And the value is equal to val. Then we have our accessor, which returns the value. Accessors are always constant. They don't change things. We have our mutator, then just a simple display function. Okay. This that displays what's in the box. Okay. So the way we're going to use this with a class is we're going to send along the type in the constructor in angle brackets. Okay. So we're going to say box angle bracket int that creates an instance of box to hold integers. Okay. We're going to call it int box. We're going to send it 1, 2, 3. Okay. We're then going to display that. Then we're going to do the same thing with doubles. Have a box, angle bracket double. There are no spaces there. It's right next to it. Okay. Double box with 456.789. Okay. Display that. Within, we can create a box for strings. So we can say box angle bracket string box. It's going to be hello world. Display that. Okay. We can then use our mutator function to set the value to goodbye world. Okay. And again, string box, we know it contains a string, and this is a string. The goodbye world's a string. So we're good. We can then display that. Okay. So pretty basic, pretty straightforward, but it turns out to be a really handy thing. So when we get to our first major data structure, it's going to be a linked list. Okay. We don't have to worry about creating a linked list where each node stores just an integer or just a double. We can template it, and once we template it, we can have that be whatever type that we specify. Okay, which is pretty useful. Let's go ahead and do our G++ for our class template example.exe. That should be the -o. That's our object file we're creating. And we're going to compile the class template ex.cpp. Okay, the // class template.exe. And there we go. So our box values just as we put it. And it depends on the type that's there. Okay. So that's really all there is to templates and templating functions and templated classes. Okay. And we're going to be using them a whole lot. Okay. So because it's simple, make sure that you really understand what's going on here. Okay. And then the last section of the book, which I'm not going to cover in the video because I think we've done it in class before, but just so you remember where it's at, it's in chapter 13. It's random number generations. We'll probably be creating some games of chance of some sort. And for those, we'll need that random number generation. So it talks about how to do that at the end of chapter 13, just a little example. Okay. So this was a much shorter video than the first one, which is good news. But again, there were a lot of videos this week, but it's important. Everything until the last 2 videos has been reviewed. So make sure you go through those before. But this is the new stuff for this week. Okay. And take a look at the problem set as you're working on them. Or if you just have questions in general, make sure that you let me know.